Salam ladies and gentlemen, today we are going to explain how to write the electronic configuration for atoms. We have only one objective, is to write the electronic configuration for different atoms. Let's start. As you know, everything around us is made up from atoms. Atoms, in fact, they are made up from two different areas. At the center we have something called the nucleus. In that nucleus we have two different particles. I will draw them in two different colors. We have the gray particles, which are positively charged particles. We call them the protons. And we have no charged or neutral charged particles. We call them the neutrons. So protons and neutrons are both found inside the nucleus. Now around the nucleus we have something called electronic shells. In fact, these electronic shells are not circular. I drew them like this just to make it easy for you to imagine how we're going to distribute the electrons on these shells. So on these shells we have tiny particles, we call them electrons. These electrons are negatively charged particles, and as I told you, electronic shells are not circular. Their shape is a little bit more complicated. We are not going to talk about the shapes because our lesson now is just how we are going to distribute the electrons on these electronic shells, or as I told you, we call them in some books electronic clouds. For you to imagine the case with the electronic shells, you have to imagine that we have a running track as the one shown in front of you, and we have four runners. Each one of them is running through one track. Do you think that they need the same amount of energy to make one rotation? For sure not. Because the one is using the blue track will use less energy than the one is using the green track. And the same thing is happening with the electrons. Electrons with lower energy, they choose the lower energy shells, while the electrons with higher energy, they move through the higher energy shells. So usually electrons are distributed according to their energy through the different electronic shells. Now imagine that I want to make a closer look at these tracks. I want to cut a small part from that red track and I will look to it under the magnifier. What I'm going to see in each of these tracks. When we look closely to that red track, we found that inside that track we have subtracts. These subtracts, they need different amounts of energy. Like as you can see, we have the S subtract, we have the P, we have the D, and we have the F. So inside that fourth shell or fourth electronic cloud, we could find subshells. We call them S, P, D, and F. And as you see that each one of these tracks needs different amount of energy. Now the question, which one do you think has the least amount of energy and which one has the most amount of energy? It's clear that S, which is the straight one, needs the least amount of energy, and P needs a little bit more, D a little bit more, and F a little bit more. So now we have shells. As we go higher, we need more energy. Subshells, as we go from S to F, we need more energy. And now is the most important part. I want you all to look at the distribution of these subshells. In fact, we have the S subshell, it can hold maximum 2. P can hold maximum 6, D can hold maximum 10, and F can hold maximum 14. These are the subshells. So the first shell, we have only one subshell. The second, it has 2 subshells. The third, it has 3, SPD. And the fourth, it has SPDF, and so on. Which means that the first shell, it can hold 2 electrons only. The second can hold 2 and 6, 8. The third can hold up to 18, the fourth up to 32, and all the rest, they will carry the same amount of electrons. In fact, it's a little bit difficult to predict the order of these subshells, because later when you go to the higher energy levels, the order of the subshells becomes a little bit complicated. For you to know the order of these subshells, the only way is to draw the table which is in front of you. And it is very easy to draw. Just put the numbers from 1 to 7. In front of 1 put S, in front of 2 put S and P, in front of 3 put SPD, in front of 4 put SPDF, and continue putting SPDF in front of 5, 6, and 7. Then draw lines horizontally and vertically to separate the numbers and the subshells, and listen carefully to the next step where we have to put the subshells in order. Now look at this step. We have to join the corners with an arrow pointing downward, as you can see in front of you, and then we draw another one parallel to it. We join all the corners with arrows, all of them pointing downward, as you can see. We will start with the first arrow. As you can see, the first arrow is passing through 1s. So we write 1s, and s holds 2, so we put 1s2. We look now at the second arrow. The second arrow passes through the s also, 2s, and it holds 2, so I put 2s2. Let's move to the third arrow. The third arrow is passing through 2p, then 3s. So I put 2p, and p holds 6, so I put 2p6, and then 3s2, the fourth arrow. As you can see, it's passing through 3p first, then 4s. So I write 3p6, 4s2. Now arrow number 5, as you can see, it is passing through 3d, then 4p, then 5s. So I write them in order: 3d10 because d holds 10, then 4p6, then 5s2. Sixth arrow now, passing through 4d, 5p, then 6s. I put them also in order: 4d10, 5p6, 6s2. The seventh, passing through 4f, then 5d, then 6p, then 7s. I want you now to pause the video, try to copy that table and follow the same procedure with the remaining arrows to get the whole sequence of electronic configuration. And before I show you how to use this sequence, I will give you my easy way how to memorize them, because it's a time-consuming process to write this table every time you want to use it. Now the easy way is for you to memorize this song, or what do we call it, the rhyme, which is sis, pis, pis, dips, dips, fa, dips. Again, sis, pis, pis, dips, dips, fa, dips. If you memorize this, then you can write the electronic configuration for any atom easily. After we wrote the sequence of the subshells, cis, pis, pis, dips, dips, fa, dips, we start numbering the subshells. S, we put 1, then 2, then 3 in order till 7, then P. As you know that we don't have P subshell in the first shell. It starts from the second shell. So we put 2P, then the next one we put 3, then the next 4, 5, and 6. D now, as you know that D subshell starts from the third shell. So we put now 3. The next one is 4. The next one is 5. And F starts from the fourth shell. You can refer back to the table that I explained at the beginning for you not to be confused. Now we have to put the number of electrons above each subshell. All the S, they can hold 2 electrons. Then the P, all of them they hold 6 electrons. The D, they hold 10 electrons. And the F, it holds 14. Now please listen very carefully, because now we are going to learn how to use this sequence of subshells in writing the electronic configuration for different atoms. I will give an example. Imagine that they ask you to write the electronic configuration for calcium 20. Calcium 20, it means that it has 20 electrons, and these electrons you have to distribute them on the different subshells. We have to start with them in order. The first subshell is 1s2, so we start with 1s2. Then the next one is 2s2. The third one is 2p6. As you noticed, I'm following the order of the sequence which is above. And at the same time, I want to count the number of electrons in these subshells. Now we have 10. I should continue till I get 20. So I will continue following the order of the subshells which is above till the number of electrons at the top we get them 20. So now I'm following the same order: 3s2, 3p6, so now we have 18. Now 4s2. If you count the electrons at the top, you can see that now we get 20 and we have to stop. And this, what do we call the electronic configuration for calcium. Let's move to another example about indium with atomic number 49, which means that we have 49 electrons. I will take the order from the above sequence. I will do it faster. As you can see, I'm following the same order as the sequence above, which you have to memorize. As I told you, you can memorize it easily through the rhyme: cis, pis, pis, dips, dips, fa, dips. Counting till now we get 30. We continue till 49. After 3d10, we have 4p6, then 5s2, then 4d10. Let's count them down. Now, as you can see, we have 48. We still need one more. After 4d10, we have 5p. But can we put 5p6? No, we cannot, because we need only 1 to complete the 49, which is the atomic number. So we stop at 5p1. And now I think that you are ready to start solving any question about electronic configuration. There are a few exceptions that I'll explain them in another video, but don't worry about them because there are very, very few cases. As I told you, don't worry about them. Start doing electronic configuration. You are ready for that. Thank you. Now it's your turn. Please pause the video, copy the questions, try to solve them, check the answers in the description below, and thank you.